We're just waiting for our sound engineer. Okay. I'm Chuck Kernler. I'm Vice President of Prairie Smoke. The event today is co-sponsored by the library, of course. Prairie Smoke, an organization of prairie fans, and the Friends of Indian Heights. And for those of you who are unfamiliar with Indian Heights, it's a wonderful park in the city limits of Rochester. It's a jewel, and really you would all enjoy visiting it. I hope you have a chance if you're unfamiliar with it. I could call this a matter of housekeeping, but I was wondering if any of you saw me on Around Town with Robin Wolfram. Okay, well, I did great. I was wonderful. But I want to mention that the handouts that are available are also on the website for the Friends of Indian Heights. And that website is very easy to find. It's a wonderful website. It has lots of information about the park. It's foih.org, and it's very enjoyable also. Now, if any of you are interested in being on an email list or joining Friends of Indian Heights or Prairie Smoke, Don is going to pass out a clipboard with paper and pen so that you can sign up and note your areas of interest. We are privileged today to have presentations by two wonderful speakers. Todd Osweiler is from the City of Rochester Public Works and Rochester Public Utilities, sorry. Barb Huberty was with Public Works, and she's going to talk about what she does now. So I don't know who's first. Thank you both for coming.
You're welcome. My tendency is to be at the side, and I was told stay away from the speakers or we'll get feedback. Mic'd up here. Can you hear me in the back? Good? Great. Well, I'm so pleased to see all of you today. I thought, oh, it's cold. Who's going to want to leave the comfort of their nice warm couch under a nice good flannel blanket? It's just like too miserable to be out. So really appreciate that you made the effort today to come. The genesis of this presentation is really kind of humorous because Dawn Littleton from the Friends of Indian Heights had come into my office when I was working for the city at one point, and we were talking about some of the landforms near the Friends of Indian Heights Park because she was working on a grant, and I was able to show her through our geographic information system a lot of information about the landforms around that park and how they formed. And she was captivated by that and said, gee, that would make such a great presentation. So we did this, gosh, Todd, what was about 6 months ago out at Cascade Meadow. And Dawn said, we need to do that again. So she asked us to make another commitment, and we did. And then in the meantime, I took another job where I have left Rochester. I'm in the process of leaving Rochester. And I've gone to work for the newly reformed Legislative Water Commission, which was actually first formed by statute 25 years ago, and that was the group that created our first Groundwater Protection Act, which was quite forward-leading nationally at the time. It was a 5-year sunsetted commission, and their other mission was to launch the county water planning process. So once that goal was accomplished, the commission sunsetted, and they didn't see a need for it in these intervening years. And now, because of several things that are happening in the state, a statute was passed last year to reactivate it. And the legislators are quite interested in the groundwater, surface water interaction and competition that's happening, especially in the metro area, and the fact that we're still continuing to see increased nitrate concentrations in our groundwater and surface water, despite a lot of conservation practices. And I think for the first time, Minnesota is realizing that our water supplies are not endless. And if they're not endless, we're going to have to think about competition and how do you square away who gets to use what for what purpose. And so over the next 5 years, the legislature is going to be tackling these sorts of issues and then making decisions about how they're going to take that information and apply it to future legislation. So it'll be an exciting time in the legislature for water. But today, we're talking about Rochester's rocks, water, and landscapes, and how specifically water made the rocks that we stand on, and the rocks affect the water that we use today. And as he mentioned, Todd's with Public Utilities, and I was with Public Works. So there's 3 main principles. One is that water formed our bedrock, and it's hard to imagine that it's possible for a body of water to form rock. But that is exactly what happened, and I'll explain why. Because it's all related to the sediments that were deposited on the ocean floor many, many, many moons ago. And today's landscape was also carved water, first by the glaciers in the form of ice, and then because of the meltwater that came as the glaciers receded, and as we continue to get precipitation today. And those are really important in because of the type of bedrock that we have, is a type of bedrock that is called karst, and it's very easily weathered and eroded by water. And because of that, all of the water decisions that the city of Rochester has to make related to our water supply and our stormwater management are dependent upon knowledge of our groundwater. So I'm going to take you back 4.5 million years ago, and we're going to take a really fast tour through time. And I'm sure most of you remember this from some past time in your childhood when you got to learn about the prehistory of the Earth. But the Earth formed down here. Whoops, come back. Come back. All right, Todd, how do I do that?
Click the button underneath, maybe, to get that little screen up. Button under here.
Aha, thank you.
Yep.
Let me see if I can back up here. I wanted to do this. So here, 4.5 years ago, the Earth formed, and this entire period was called the Precambrian era, and that was an era with no life. And it got divided into 3 different eons based on the types of rocks that were formed and the conditions that were happening, but there was no life during that entire period. And then we move into the Phanerozoic era, which is the era of life. And it's really, think of it as big life, when bigger life forms started to appear on Earth. Algae actually formed at 2 billion years here, but only unicellular animals existed during this time. So all of this time that went past, it was like nothing was really happening that would be of interest to us. But remember this Precambrian, and we're going to look at this era expanded out here. But here at 2.7 billion years ago, Minnesota was underneath an ocean, and there were volcanic islands in that ocean at the location of what would have been northwest Minnesota. So does anybody remember the type of rock that forms from volcanic activity? Granite's a good example. Basalts, like have you been to the North Shore? Most of the North Shore of Minnesota rocks are volcanic types of rocks. So those are the kinds of rocks that are buried deep in northwestern Minnesota. And when you look at a map of Minnesota that shows what kind of bedrock is present where and what the ages of that bedrock are, you can see that all of this part of the state is underlain by Precambrian bedrock, that very, very old rock. The next oldest rock is the Paleozoic sedimentary formations, and all of southeastern Minnesota is underlined by those. And then in southwest Minnesota, we have even younger formations, and they are also sedimentary formations, but it's a different type of bedrock. So if you look into the Phanerozoic era, that was the one that was really skinny on the first page. When you stretch it out, you can see the names of all of these different periods. And this Phanerozoic period is broken down into 3 segments: the Paleozoic era, the Mesozoic era, and the Cenozoic, or I should say period. Paleozoic period, Mesozoic period, and Cenozoic period. And the Paleozoic is when we had very ancient life on Earth, and the Mesozoic is when we started seeing dinosaurs on Earth, and the Cenozoic is when we started seeing mammals appear. So if you go back to that first page and you see for all that 4.5 billion years, this is compressed into that shortest time period, that what we think about as recognizing Earth today has been very recent. So now I want you to think about not only the kinds of life that was present, but where the land masses were and how they were being formed at that time. So in the Paleozoic era, in the oldest Cambrian period, that was 514 million years ago. And at that particular point in time, there were tropical shallow seas. And so the North American continent wasn't even forming yet, but this is where it's going to end up. So some of you may have heard of Gondwanaland, kind of that big, massive continental landmass that existed before the continents broke apart. And you can imagine that during this time with these shallow seas, that sediments were eroding off the land masses and moving into that ocean. And as they got to the ocean, they'd settle out to the ocean floor. And over millions and millions and millions of years, that sediment just kept stacking up deeper and deeper and deeper, because you had some places where there was land lifting, and when it got high, any water would help move that sediment off the land and into the water. And at this particular point in time, the equator was right smack dab through the middle of Gondwanaland, and the location where Minnesota would have been had that little section right here in the northeast part that was actually part of the landmass. But down here, where Rochester would be, why is it blue? It's underwater. It's still part of the ocean. So during the time when this part of Minnesota was underwater, there were sediments that just kept piling on. Then we moved to a closer period in time, the Ordovician period, that was 458 million years ago. And in this period, the sea level was going up and down and up and down over a long period of time. And so there were 3 different kinds of marine sediments that were being deposited at that time: limestone, sandstone, and shale. And if any of you have driven around Rochester and you see a good road cut through an outcrop exposure, you're going to see examples of that sandstone, limestone, and shale. And the Devonian period, 390 million years ago, that was when Eurasia started forming as the plates were starting to join, but we were still seeing sea level going up and down, and more marine sediments were being deposited. Oh, I did it again, Todd. Where's that magic button?
It's kind of
There we go. Thanks. I'm not used to this one, obviously. The Mesozoic era, 94 million years ago, that's when the continents started drifting apart, and we start seeing the continental shapes similar to what we see on a map today. And here's North America over here, and you can see this would be kind of like where the spine of the Rocky Mountains would be today. But what was there then? Water. And if you've been out to the Rocky Mountains, you know that big sections of the Rocky Mountains are sedimentary rocks that formed at the bottom of this shallow sea and were later uplifted. But here in the middle of the continent, where Minnesota would be, we actually got to be land for a while. But as those sea levels rose and fell, we would sometimes be underwater and we would sometimes have exposed land. And here, Minnesota's right on the edge of that, and here now, southeastern Minnesota actually had a land mass for this point in time, but the western part of the state was underwater. So if you remember that white map I showed you, and it said that in southwestern Minnesota we had younger sedimentary rocks, that's because they were being deposited as a result of this inland shallow ocean. So 14 million years ago, you know, that's like yesterday in geologic time, a blink. Now we're into the Miocene period, and you really see the distinction of how our continents look today. So over 4.5 billion years, all that was happening as these continents were forming was a really important process of sea level rise and fall and sediments washing into the oceans, depositing on the floor, and then when those sediments, they compressed at the bottom of the oceans, and then they were later raised up as those ocean floors were pushed up through other forces so that they form the landmass that we have today. So I mentioned this word before, we have something here called karst. So our limestone, sandstone, and shale, because it's very close to the surface, it's easily weathered by precipitation. And because of that, it forms solution channels, fractures, fissures, vugs, caves, sinkholes. And that is all because the carbon dioxide in the air mixes with the water. It makes the water slightly acidic, and that slightly acidic water is very good at dissolving sedimentary bedrock. So these are examples of features: disappearing streams, sinkholes. Here's one where it's collapsed. Here's a valley that's been created because sinkholes coalesced as the water moved through. But as water moves across this landscape, there's usually not very much superficial soil on top, so the water moves very quickly from the ground surface and into the bedrock. And this particular picture isn't the best depiction, but throughout all this bedrock, it's filled with water, and that's the water we pump up to drink. So you can imagine if we had a spill here, and it's directly connected to this limestone underneath, any contaminants that are on the surface have the potential to quickly go into our drinking water supply. So there are different things that control where bedrock, these karst features form in bedrock. The type of bedrock, how deep it is to get to the bedrock, the type of soils that are overlying, all of those are important factors. Because we have some places in Olmsted County where it's 150 feet deep of clay soils above the bedrock. You don't see solution features there because it's too far below. It's only where the bedrock is very close to the surface. But this type of bedrock system that we have here, we have springs, disappearing streams, and sinkholes, and they're all related to different bedrock types. So, I should have mentioned, I gave you a whole bunch of handouts, not because you're going to learn them today, but because you're going to think about this and want to go back and reference it. So I gave you another geologic chart that has more information about the types of life that were living at those times. And now, excuse me. These images come from what we have in the city that's called a geographic information system. And it's a way to plot data in a geographic way so that you can overlay that data and use it to help evaluate and analyze the physical. So this first one, what have I got first here? This is the first encountered bedrock. So if you imagine you stripped off all the soils and you were on Highway 14 where it came into Highway 52, you'd be on that very light yellow. And that's the Prairie du Chien group, which happens to be a limestone. If you were at where I-90 crosses 63, there you've got that darker purple, and that's called the Galena group, and it's specifically the Stewartville Formation. And all of those in the Galena group are limestone also. So you can see as you look at the names here, all we have here are limestones and sandstones and a shale. And this next picture shows the depth to bedrock for this county. So where it's white, that means that the depth of soil above the bedrock is less than 25 feet. That is a very, very thin layer of soil. But you can see over here in the western part of the county where we have some of the more color going on, these are actually buried bedrock valleys. So you can imagine when the glaciers came through, they washed out large valleys because of the large volume of water that was coming, and they carved very deep riverbeds through here that later filled with sediment. And so these are the areas where we can get up to over almost 300 feet of sediment on top of the bedrock. So in these buried bedrock valleys, you're not going to see any sort of karst features forming. But in this eastern part of the county where there's no soil, the karst features form quite regularly. So this next picture is not going to be anything you have as a take-home test. This is just the type of soils that exist. And the reason I included this was just so you understood that we have many, 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 many different soil types present, and they help determine whether or not, as water moves through the soil, whether those contaminants can be filtered out. If you have a sandy soil, contaminants don't get filtered out very well. If you have a clay soil, the water doesn't move through very quickly, and so the contaminants will get filtered out. So if you have deep clay soils, you've got more groundwater protection than someplace where you have a thin mantle of sandy soils. This next one shows the location of springs, and it's shown on top of the bedrock layers. And the reason I did that was so that you could see that springs don't form everywhere. And as you learn about geology and you learn about the locations of springs, you come to learn that, gee, we have most springs happening in this upper Galena aquifer, specifically where that upper Galena aquifer has been eroded and it's meeting that edge where the Decorah Shale is, and then the St. Peter sandstone below where the water will re-infiltrate. And Todd will talk more about that as it relates to our water supply. But springs give us some geologic clues about how water is moving through the system. And similarly, on the next one, I've got sinking streams. And we don't have as much information about that in Olmsted County, but you can see there's a couple of these purple dots. And those are places where the stream will be flowing along the surface, and then it will seem like it disappears. And it does disappear. It goes underground. And so it dries up because of this sinkhole or sinking feature. And those, again, are happening in that upper limestone aquifer. And the sinkholes, even though it's karst, we think of our whole county as being underlain by karst. Not all of our county has all the karst features, but sinkholes are another karst feature, and again, they tend to predominantly exist in that upper Galena aquifer where it's very close to the surface and not very thick soils. So if you were to go southeast of here to Fountain, so what county is that? Fillmore, and what's just north of it? Winona. Both of those counties have more sinkholes than we do because of their location in the geologic plateau. So with that, I'm going to come here. And with all of these handouts, they're just meant to demonstrate how we use that type of information to assess where did our rivers once flow. So we know that where we have a buried bedrock valley, a river once flowed through there. But the topographic elevations also are a good indication. And if you look at this map, this is what's called a LIDAR map. So this light ranging and detecting radar is a type of technology that helps us determine ground elevation through remote sensing. So we don't have to go out anymore and take the chain and the rod to do surveys to find out topographic elevations anymore. We can use remote sensing techniques and get excellent resolution on landform elevations. And this particular depiction shows that the browns are higher in elevation and the grays are lower in elevation. So you can think here, all these grays here, although there is one color on top, I don't like that, but that's all part of that Galena plateau where we had the upper aquifer and all the sinkholes and all the springs are at higher elevations because they're the higher first bedrock with water seeping through them. This bluish and greenish area is the valley that's been carved by the Zumbro River, and that's why it's showing it as a lower elevation. So you can imagine over in western Olmsted County where our buried bedrock valleys were, that was the post-glacial location for the Zumbro River. but then it got choked out with sediments and it shifted and it moved to its present day location. But you can see the distance across this river valley is quite wide compared to the width of the stream. And that's because the stream used to be much bigger in its post-glacial era, and it carved out that valley. And today, as the glaciers dried up, and we're only left with the water that we get from snowmelt and rainfall, we have a very narrow water course, but the old wide valley still exists. And if you flip over, you can see that kind of a close-up of just Rochester, and you can see that that's not only true for the Zumbro River that goes north and south, but all the tributary streams also have wider valleys due to that post-glacial runoff when we had huge volumes of water coming through and carving. So all that water activity from 10,000 years ago carved the landform that we see today. So those topographic elevations show us that today's riverbanks are not the same as where those riverbanks used to be. The depth to bedrock shows us where the buried river valleys were. And then we can also look at the location of sand and gravel deposits because those tend to be stream deposits. And did I remember to include that? I did. So here this map shows where we have different types of aggregate resources, sand and gravel deposits that are mineable. And lo and behold, they kind of follow where the rivers go because they were deposited by the post-glacial rivers and continue to deposit those kinds of sediments today. So the rivers, where are they flowing today? Take a look at the next one. This overlay shows the floodplains that are designated by the Federal Emergency Management Administration, FEMA. So you know about FEMA after floods. But FEMA does floodplain mapping and flood protection work, and they've identified those areas that are still prone to flooding today, either in a 100-year storm event or the wider light blue would be a 500-year storm event. So those are areas that you can expect to be flooded during a flood today, or what we would call a flood today. And not surprisingly, what's happening is that when the water level gets higher in the rivers, it flows out into the old valley that was created by those post-glacial floodwaters. So our landforms tell us what happened in the past, but they also tell us what's going to happen today. Elevation means so much. This last diagram is a picture that shows in great detail the underlying bedrock formations that we have. And Todd will refer to some of these when he's talking about our water supplies in a bit. So once you know a little bit about how our geology formed, it's important to understand that that geology still informs the processes that are going on today. So because of the type of bedrock that we have, when precipitation falls on the ground, it goes in and it runs off. And depending upon where the water table is, so when water sinks in, the upper part tends to be drier, it's not holding water, but it eventually reaches an elevation where it's saturated. That saturated area is called an aquifer, and RPU drills their wells into this aquifer, and that's where we pump out our water from. So it's really important to think about here, if we have a stream on the top, one of those sinking streams where it's losing water because the water wants to get down to the elevation where water is, it's going to leak out of this stream and that water is going to recharge our aquifer here, whereas the Zumbro River is actually being fed by groundwater moving in to feed it. So we have two kinds of streams. So if this stream were polluted, it would add pollution to the aquifer. If our aquifer was polluted, it would add pollution to our streams. So we have a huge groundwater, surface water cycle here in Rochester that's very, it communicates really well. And you can imagine then if we are putting pollutants on our land, if we're over fertilizing, those excess fertilizers, some of them are sinking in through recharge and some of them are running off. And in the city, since 1985, we've been building stormwater ponds to capture that overland runoff. And we have plants, and through detention time and filtration, many of those pollutants are treated. So these serve as little tiny wastewater treatment plants for surface water. And you can see we've got a street here with a catch basin that's connected to a storm sewer that goes into the pond. The pond has an overflow outlet that goes into the stream. But anything that was built before 1985 has absolutely no surface water treatment. So then anything that's happening on the land runs off directly into our surface water or filters down into our groundwater. So it's really important that everybody, whether it's a business or a resident, that everybody's thinking about what they're applying on the land, because what gets applied on the land can impact the quality of both our surface and groundwater. So one of the things that what happens in the city when a new is proposed now because of the new regulations for stormwater management, they have to calculate, well, where is the water going to flow and how much water is there? And in doing so, they have to plan their storm sewer system. Whoops, excuse me. All these pink lines are the storm sewer system, and this particular set of storm sewers are draining this entire area, and it flows into this stormwater pond. And we had something kind of unusual and unexpected happen with that pond. This is how it looked when it was built, which is exactly what we wanted. We wanted that wet retention so that the water would get the advantage of being treated by all the plants, by sunlight, and by sedimentation. But over time, we started seeing this. And we thought, what on earth? This is not supposed to be happening. And what did we do? We went and we looked, and oh my gosh, this particular pond was built on top of the St. Peter sandstone, and the construction of it did not have a liner that was sufficient to prevent that kind of leakage. So the city's going to have to decide, do we want to use this as an infiltration pond where we actually intentionally recharge the groundwater with stormwater? Or are we worried enough about contamination that we need to do something else to line it and fix it? This was an example of planned infiltration at Quarry Hill Park. We had this development around at Parkwood Hills was built in the early 1980s, before any stormwater management requirements existed. And there were several places where we were seeing really severe erosion on the hillside here and in here. And so we had to go in and do a fix. And so as part of the fix in putting in storm sewers to convey the water, then we created a wet detention basin. We put in native vegetation all through here, so any overland flow would get treated by those plants. And then this basin is an intended infiltration basin. So we want the water to be treated, we call it a treatment train, through these other avenues before we put it into this infiltration basin. And it's really great because Quarry Hill Creek flows through here, and that makes sure that some of the base flow to Quarry Hill Creek remains. So when a city or a developer is working on putting together their plans for development, they have to provide for groundwater protection. And so they have to ensure that the separation distance between the bottom of this best management practice and the water table or the top of bedrock has to be 3 feet. So between here and here, it has to be 3 feet. And that's felt to be sufficient filtration for the type of pollutants that are carried through residential areas. It's also important to understand our geology as it relates to fen and wetland protection. Fens are a type of groundwater fed wetland, and other wetlands tend to be surface water fed. And where am I? I'm here at Quarry Hill, so you all know where the Nature Center is, right here, right? And if you were to, that's the old pond, this is the new pond. So in this particular area, we have a valley that's cut through here, but this is that upper aquifer again. So here's that Galena limestone group, and then here's our Decorah shale that Todd's going to talk more about. And at the edge where water is coming through the galena and then comes across these terraces, you tend to see wetlands forming. And these wetlands all survive because they're receiving groundwater from that upper aquifer. So think of it as a layer cake. You've got the upper aquifer up here, and then you've got a shale that's pretty impervious, and then you've got a lower set of bedrock that's also limestone. So when the water is coming through that upper aquifer, it hits this, it can't go through, it's got to go off. And so it moves off following elevation until it reaches an edge, and then it can go over the edge and sink into the rock that's underneath. And that's exactly what's happening here, and that's why we get these wetlands, because the water stays on that clayey edge for long enough that wetland plants can form. And you can see we had a couple of little fen restoration projects that we did as part of the big Quarry Hill project. And from here, there's this little, we call it the Quarry Hill Creek, that comes into here and then on into Silver Creek. So these little wetlands here are actually the headwaters for Silver Creek that later drains to the Zumbro River. So even though they're little, they're really important, not only as a continuous water recharge source, but because of the unique ecosystem that they have. And with that, I'm going to turn it over to Todd. Oh, you have your... You told me not to do that. Anyway, I'm so sorry. How do I turn it?
Must be my mic. Okay. Everybody hear me okay? Hear me in the back? We're good. Okay, my name is Todd Osweiler. I'm with Rochester Public Utilities. I've been with RPU for, God, almost 20 years now. So I did my first internship summer in '95, and they kept me around forever. So hopefully I'll have another 20 more years with RPU, so it's been a great place to work. But I'm going to talk a little bit about RPU's water system, the geology, hydrogeology in our area, the groundwater quality and treatment that we do in the city, water sustainability. That's kind of a phrase or a word you hear all the time now due to water quantity issues. You hear it in southwestern part of the United States, but you're also seeing some issues here in Minnesota. So DNR is making some big changes to how they permit how much water we can use, and I'll talk about that in a little bit. And then, so since we have a great, quantity and quality of our water, we have a wellhead protection program too, and I'll talk a little bit about that. Okay, so Rochester's water system, we're a city just over 100,000 now, plus all the visitors that come primarily for Mayo Clinic. We have 37,800 total water customers, so that's a meter. If there's a meter, that's a water customer. Out of those, about 38,000 now. 34,000 roughly are residential, almost 4,000 commercial, and 38 industrial water users here in Rochester. We do have 32 groundwater wells spread throughout the city. They're hard to see, so wherever you see a water tower doesn't necessarily mean there's a well there as well. I have another slide that shows kind of the dispersion of all of our wells that are throughout Rochester. We have 20 water storage facilities that total over 15 million gallons we can hold in water storage. So we try to have enough water storage for what average daily use here in Rochester is about 12.5 million gallons. You know, that obviously changes in the summertime use, but on average, it's about 12.5 million gallons a day. Our wells range anywhere from 400 to 1,000 feet deep. I got some slides that show kind of the layers that we drill down into. Primarily, we're down into the Jordan Aquifer is where we get most of our drinking water from. All drinking water standards, you know, are met. That's the state and federal drinking water. We're lucky here. We're unique. We're the largest groundwater system in the state. We don't have to treat our water at like a central water treatment station. A lot of larger communities, St. Paul, Minneapolis, part of their water does come from the Mississippi River, so that has to get channeled into a water treatment facility before it gets out into the distribution system. So we're a little bit unique like that. We do some sort of treatment right at the well houses, and I'll talk about that in a little bit. 2013, we used about 4.7 billion gallons a year. So 2014 numbers are in. It was 4.7 billion gallons again. We've been pretty steady at that. We are permitted or allowed through our DNR water appropriation permit to use 5.7 billion gallons. Our projected, we'll probably be about 10 to 15 years before we hit that level. We've been at that 4.5, 4.7, pretty steady over the last 10 years. I think 2007 was our biggest pumping year ever, and that was just over 5 billion gallons for the year. This is just a list of our top 10 water customers. Of course, Mother Mayo on top of that list. The city of Rochester is a high water user, and you can see some of the industrial customers like Seneca, Crenlo. The hospitals, Methodist, and St. Mary's are also some of our larger water users.
Todd, why is the city so big?
That's a good question. A lot of that, I think that slide, I have to go back and do a little research on that because some of that was the Silver Lake plant uses surface water, and I think that got put in there. And that's primarily for cooling. We don't burn coal or generate electricity down at the Silver Lake plant, so we aren't using that water source. Here's a list of all of our wells. So you can see where all 32 wells are spread out throughout Rochester. And basically where the new wells are going in is where there's new growth. So our newest well is well 40. This is out by Willow Creek Reservoir. That's where that one was drilled. And that we sealed the airport well that was out there. We had a well at the international airport that got sealed. So that was this is a much higher production well, so we went ahead and sealed the airport well. Our new well is going to be right about here where the college is. So that'll be our well 41 that's set to come online this spring. About every 2 to 3 years, we typically drill a new well.
Which is the oldest well?
Oldest well would be number 11 right here. Soldier Field. So back in the day, they started with well 1, 2, so on. So you can see 11, 12 still in production, 13, 14's been sealed. And, you know, as we grow, we're into the 40s now. Now, of course, you see these 70, 72, 77. What those are small system wells. So it's a community that might have 15 homes on it. And as the city grows, we'll buy those small systems, tie them into our larger distribution system, and then eventually those smaller wells do get sealed as the city grows. Yes?
Up at St. Mary's Hill.
Yep.
That's a water tower.
Yep. Yes.
Classified as a well there? Or
No, there is no well there. Yep. So that's kind of a misconception, and that's, you know, something, if there's a tower, there's a well. Well, that's not really the case. There is 2 examples, like Apache Mall. There's a water tower there. There is a well right below that tower, and then one in Country Club Manor. So those are the only 2 cases in town that there's a well in a tower. But yeah, that St. Mary's, that's just water storage, and that's a 3 million gallon tank. So that's one of our new ones. So this just shows all of our wells here are listed on the bottom. Again, these are 2013, but on average, 2014 will look very similar. You can see well 36 is one of our better producing wells, you know, and it's almost 500 million gallons for that year. Some of our lower producing wells, you can see some of these smaller systems, the wells that are in the 70s. And like well 12, that sits right down by Silver Lake, down by the power plant. That well just is primary for summertime use, peak time use. So we have a few wells like that, well 19, well 12. So some of these wells don't run, they're not very good producing wells. Some of our better producing wells will run literally nonstop. So we cycle them on and off, but just shows you a shot on where some of our better producing wells are. So here's an example of two well logs, well 20 and well 36, and you can see how deep well 20 is. This is one of our deepest formation wells, and this was drilled, God, I want to say this one was back in the 60s, but they drilled it all the way down to the Mount Simon. Now all of our newer wells, well 36, this is by the History Center. We have a well right there, right below the Decorah edge. And you can see we drill down into the Jordan. So this Jordan is a sandstone, it's a Jordan aquifer. So you can see where this blue is, that's where it's cased down to. So this well is cased down into the Jordan, but it's open formation through all of these other aquifers. Now we do have some ammonia issues with well 20, so when you go deeper doesn't necessarily mean better. So, and I'll talk about that in a little bit. But all of our wells, Minnesota Department of Health regulates on how our wells are developed, and right now we're casing down into the Jordan, and then we stop drilling right into the St. Lawrence Formation. So primarily this is our water source. So as I talked about the Jordan aquifers, and this is on the handouts, I believe, and you can see where the St. Peter, Prairie du Chien, Jordan. Well, I'll talk about those quite a bit today. But most of our wells now are down right into this Jordan layer. And you can see there's different types of sand in this Jordan sandstone, which makes some of these wells a little bit more better producing wells. Our better producing wells are on the southwest part of Rochester. They're just better yielding wells. Just the sand in that Jordan formation, it allows the water to move through there a little bit more than what we're seeing on the northwest part of town, where a lot of the new growth is going. So primarily most of our water, it's going to be coming from these geologic layers, the St. Peter, Prairie du Chien, Jordan, because they're hydraulically connected. So that water Barb talked about, the Decorah edge, that sits right here. That's kind of that cap, that shale, that protective layer, but that's not present everywhere in Rochester either. But where it is, that offers a layer of protection for the aquifer. But primarily it's the Jordan aquifer where all of our drinking water is coming from. I don't see this advancing. There we go. And this shows all the geologic layers. I'm going to start peeling these back a little bit. But the first one is the Cummingsville Formation, so that's the highest elevation here in Olmsted County. And as I peel these back, we'll get down into past the Decorah, St. Peter, Prairie du Chien, Jordan. Looks like I got to click about 4 times to get these to go. So there's the Decorah shale layer, and you can see where that's present in Rochester. And the Platteville, now we're down into the Glenwood, that's part of another confining layer. Then you get into that St. Peter sandstone. So we're the not Chateau Theater, it's what's the name of the theater right behind Shopko North? Is that Chateau? Okay. So right there you can see that St. Peter sand cut right there. That's a good example of where the St. Peter is present. And a lot of the roads that are constructed in Rochester, they'll cut through some of these layers. Here's the Prairie du Chien, and the Jordan is present throughout the county. So, and again, those are all the layers. Here's kind of a water table from the St. Peter, Prairie du Chien, Jordan aquifer. So this was developed from USGS. They developed a groundwater model for us about 20 years ago. Now we've been working with the USGS again, and we've just built this new, latest and greatest groundwater model. So just starting to use it. So we're going to use this to come up with our wellhead protection layers. We can use it to model as we put in new wells, and if we adding a well every 2 to 3 years, how much water can we actually use out of this Jordan aquifer before it's going to just decline over time. So this is some of the answers that the model will help us do. And out of the model, we develop what we call the aqua shed. So you can see this from the previous, right here. You can see these high water table elevations here. So we got what we call the aqua shed, and that's created by all the wells that we have inside the city. It'll create that cone of depression, so that water is going to flow in there. So we determined, based on the groundwater model, where that water would shed. So the groundwater tables, where the water would flow into the city. Now this will change in time. Once we start using more water, drill more wells, that could potentially push this area out and make it a larger area. This is just shows where, I think I got a better slide. Well, you got a well that's drilled here. So pretend like this could be the Decorah shale. So that I add a layer of protection down into, these would be your aquifers, some sort of sand formation that holds water. And here's kind of a simple look at, Barb talked about the upper aquifer, the Galena aquifer. So then we got the Decorah shale. So anywhere, Rochester kind of sits down in the basin, but as you move out where Century High School is, or over by Country Club Manor, you got some of the higher elevations. That's where the Decorah shale is going to be present. So you can see this as you're moving up. I live on top of the Decorah shale. I live over by Country Club Manor. And when I'm driving up the hill to get to my house, right after a rain, you see all that water that's shedding off, that's coming down in the upper aquifer, gets to the shale later and it starts coming out. People that have built homes in the Decorah shale, they could act like bathtubs. All that water can get into their basement. I see it all the time after a heavy rain. I'll be driving up. You can see the flooded basements, the carpet out there, and I know exactly where their home was built. You can even see the little springs coming through the cracks in the sidewalks, driveways. So here's an example of where most of our groundwater recharge happens. So here's the upper aquifer. The Decorah shale is a confining layer, and you can see that water doesn't move through that very fast. So what it wants to do, it's going to take the easiest path, and it gets over this Decorah shale, and most of our recharge, you can see, happens right over this Decorah edge. That's why we want to protect these areas, because as the water moves through here, plants can take up nitrates in the water. Most of the nitrates are going to be in this upper aquifer, but by the time it gets down into here, you can see 54% of the recharge is coming right over that edge. So water quality tends to be a little cleaner. You know, if you're underneath that confining layer, you're more susceptible to contaminants getting into our groundwater where you don't have that present. So you can see where the Decorah shale is present here in Olmsted County. You can see it extends up to Goodhue, down into Fillmore, and then they got the same type of edge here with the St. Lawrence edge, and that's primarily down in Mississippi River Valley, down into Houston County. So groundwater, surface water interaction. Barb talked about gaining streams, the Zumbro River, where the groundwater is going to be moving towards the river. So our aquifers, but they can also be a losing stream. She talked primarily those would be in the higher elevation and they want to get down into the water table. But our pumping can cause a losing stream too. We've done some studies on our well 27, which is by Quarry Hill, and that's right along Silver Creek. So there's certain stretches of that river that were determined to be losing stretches. We've done some stream gauging in that area, and in Minnesota Department of Health contributed that to our well 27, which is one of our highest pumping wells. Well, we've done further studies. We did a tracer study to determine if that water is, connected. Is the water that we're pumping from well 27, is that affecting the flow in Silver Creek? So based on the isotope, the water quality testing, the tracer testing, we didn't see any interaction between the two. Can't disprove it, but we're going to be looking doing a lot more stream gauging just so we don't impact any of our, streams or rivers here in Rochester. And that's one thing the DNR is really focusing in on now. So groundwater quality, talked about the water that comes over the edge. You've got this, it's called nitrate attenuation, where the plants help remove some of that nitrates. They take that, use it as fertilizers, helps plants grow, but as that comes over that edge, it gets down into the St. Peter, Prairie du Chien, Jordan aquifer, and that helps clean up the water. Nitrates are a big issue for a lot of communities. Here in Rochester, on average, we're less than 1 part per million. The drinking water, the maximum contaminant level for nitrates is 10. So smaller communities like Lewiston, I'll use for an example, you know, it's a lot of farmland. They're up on that higher plateau. They do have nitrates in their water. And I know they had to drill a deeper well to get below that 10 part per million. And they actually combined the two together. They got one that exceeds the 10 and one that's below the 10. They combine it. I think they're down around that 5, 7 parts per million, so they can put that into the distribution system. So we're very lucky where we are here in Rochester that we don't have nitrates to deal with. This would be up by Century Hills, Century High School, one of our newer wells, well number 37. We've done a study there on the effects of the Decorah Edge wetlands. So you can see the upper aquifer, it's got higher nitrate concentrations. And if you remember, before all the housing developments in that Century High School area, you know, it was nothing but cornfields. Yep. And so we had high nitrates over that 10, but as that water moves through that Decorah Edge, that's why it's so important, you know, to limit where we build on that edge, because it does help clean up the water quality before it gets down and helps recharge into where the Jordan Aquifer. So we have one of our wells that sits right below the Decorah Edge. It's one of our better producing wells. And the study that we did, you can see all the water in that upper aquifer back, this is in 2004, was in that 15, 16 parts per million. So that would have exceeded the drinking water standards. And over time, and again, this is in the upper aquifer, but over time, land use has changed in that area. So the farm fields aren't there, the nitrogen, the fertilizers aren't getting into the water supply. And you can see how fast, just primarily from land use change, that this dropped all the way down to 4 or 5 parts per million. So water treatment, talked about, you know, Rochester's lucky we don't have a central water treatment plant. We do some treatment at our wells. So one thing we add, and this is a Minnesota rule, that requires all municipal water suppliers to add fluoride to the water. Some people love it, some people hate it. The range that we have to maintain is 0.9 to 1.5 parts per million. So on average, we try to keep it right around that 1.2, and we do a really good job. So it's just a small amount that gets ejected into the water as it's right when it gets pumped out of the ground, because that feeds right into the distribution system. Now the Center for Disease Control is looking to change this, and I've got a good feeling in another year or two Minnesota will adopt that. The new standard will be 0.7 will be the new average, so we'll reduce the amount of fluoride that we're putting into the water. We anticipate that to happen in the next year or two. So we also add chlorine. It's a chlorine gas. We do this for our bacteria control in the water, and on average it's 0.87 parts per million. So we try to feed around that 1 part per million, so we want to maintain some level of chlorine in the water to help keep bacteria, E. coli out of the water. So get all the water quality calls, complaints come back to me eventually. So a lot of people call and say there's too much chlorine in our water. Every time I turn it on, I can smell it. Well, that's the chlorine getting out of the water. It's escaping. It's very volatile. It dissipates really fast. So people will bring in a sample of the water and go, there's just too much chlorine in here. I'll test it. It'll be 0. Because that chlorine I have to go out to the home or the business to test it, and I got to run that cold water for about 2 to 3 minutes. It'll stay in solution a little bit longer. So technically, if you can smell it, there's probably, it isn't because we have too much chlorine in the water. It's typically just getting out. You usually get that smell from the first time you turn the faucet on. And then we also add polyphosphate, and this is for corrosion control. And we feed that into the distribution system at 0.5 part per million. And this helps protect plumbing, lead and copper. We have to do lead and copper testing every 3 years. We have to do 100 random samples at residential. So part of our lead and copper program is we have to have a corrosion control protection, and we use polyphosphate so it doesn't leach that lead and copper into the water. So groundwater age, how old is our water? How young is our water? Well, it's mixed. We've done a lot of age testing on our water, and what we have done in the past is tritium. tritium, and this is back in, I think, in the 50s when they did all the atomic bomb testing. So the tritium would show up in the water. So if we have high tritium hits in our water, we determine that's as recent as 1950. Now, another tracer that I like to use now is chlorides in the water. So with all the salts that people are putting down in the summertime, and we're seeing chloride levels trending upwards here in Rochester. And that goes back into about 1980. We had very little chloride in our water. So from about 1980, you can see that trend continue in most of our water. So that's another way for us to age date our water. But typically you can see where we call our vintage water, if it's below this Decorah shale, it's going to be somewhere mixed, maybe less than 50 years old. So this could be, hundreds, maybe 1,000-year-old water over here. This could be very recent. We'll call it 50 years or less. And this might even be, 20 years, because we see those chlorides spike in our water supply, and that's due to the heavy salt use. So groundwater yield, I talked about. Some of our wells are better producing wells than others. It's all coming out of the Jordan sandstone. Well, the Jordan sandstone isn't the same everywhere we drill. Our better producing wells are typically down in the southwest area, and we find that our worst wells are up in this northwest, and this is where a lot of our growth is going to be here in the next few years. So water sustainability, this is this big thing that's going to change a lot of what Barb's doing up at the state capitol, a lot of changes that the DNR is going to request out of public water suppliers or anybody that wants to use water. So how they define water sustainability is sustainable use of groundwater, the use of water to provide for the needs of society now and in the future without unacceptable social, economic, environmental consequences. So when we have to ask for more water, they're going to make us do a lot more things to make sure that we have a water conservation program, that we do leak control on our distribution system. I mean, everybody's heard of the White Bear Lake, what's going on up there. That's kind of what's going to spark a lot of these changes that we're going to see in the future. But what happened at White Bear Lake is that was contributed to municipal pumping. So the geologic layers were hydraulically connected. I forget what aquifer that was, Barb?
No, but the DNR does not believe it's due to overpumping by the well. It's climate driven. And it
Okay.
is because the other folks think it is due to the well.
Right. And I thought that's what the USGS determined.
Not yet.
Okay. Well, verdict's still out on what's causing White Bear Lake to decline.
I think it's the Jordan instead.
Is it the Jordan up there? Okay.
That's,
So one of the things that we're doing, we've done a lot of groundwater studies here in Rochester and Olmsted County. I mean, millions of dollars, dating way back into the 1980s, we started doing these groundwater studies. Well, we've done a lot of work. We learned about where our water's coming from. Now this water sustainability evaluation, we're using our new groundwater model that the USGS developed for us. I mean, this will replace our 20-year-old model. And we hired Bar Engineering out of Minneapolis to do this water sustainability evaluation. So some of the things that we want to know is, and questions I get asked all the time, either by people in the community or the RPU board, well, how much water do we have left? Are our trends, water levels trends declining, inclining? Well, some of our wells, they've been pretty stable over the years because we do static water level measurements. Some have shown a slight decline, and there's others that have actually inclined. So it's hard to gauge just how much longer we can keep using the Jordan before it'll run out. So one of those things that we're going to do in this water sustainability study is we projected that we're going to add 20 more years, or 20 more wells into the Rochester system. So Rochester, I mean, it's pretty defined where our boundaries will go once we meet up with Byron and how much the city's going to expand. But we figure it'll be 20 wells that we'll add. So what we did in this groundwater model is we added a well every 2 years and ran the model just to see how that would impact the Jordan. So we did all these model runs by adding all the way up to the 20 wells to see what the water trends are going to be adding those wells. So we're at 5 billion gallons a year roughly right now, and that took us to almost 10 billion gallons a year. So that's what we're modeling. The model study is still in draft, but this will be one of the things I'll be talking about and speaking out in the community once we have all the findings and the evaluation is complete. But it's very interesting because it takes into account what our impacts would be on these streams, some of these wetland features, these fens that Barb was talking about. So these are some of the things that the DNR is looking at to make sure that we're not impacting and taking the water out of the ground. So we're going to look at impacts from additional wells and impacts from extended drought. So that's a very interesting study, and again, that'll be something that, you know, I'd love to come back and talk about the findings of that evaluation. So another part, we have good water quality, great water quality here in Rochester. We don't have water quantity issues that we're aware of, and we're trying to determine with adding these 20 new wells in over time. But since we have this great water quality, water quantity, we want to protect it. So we have a wellhead protection program here, and this is something that I work with the City of Rochester, work with Minnesota Department of Health to develop these areas. This just shows a wellhead protection area is just basically a defined area. You can see a well is right here, and these are the areas that you want to protect on the surface. So here is our 32 wells again, and you can see our wellhead protection areas. Some are shaped a little bit different, and these are based on a 50-year capture zone. So we use the groundwater model to determine these areas. If something spilled right here, it would approximately take 50 years before it hit the well. That's how those areas are. Now, with the new model, we've redefined these areas, and we'll look at this a little bit closer, but they're much larger with the new model. So, like I said, our old model is 20 years that we developed these areas, but it's darn near the whole city now with our new 50-year, if we use the 50-year time of travel zones. But anyways, that gives us an area to protect around each well. So we wanted to, if there's gas stations there, so what I'll do is I'll define what our potential contaminant sources are. So what risk is out there that could contaminate our water. So we find what those risks are. If it's a gas station, we want to make sure that their tanks are, you know, the double wall tanks, they're doing tank inspections, things like that. So here's a zoomed in shot. This is our well 36. I talked about this one earlier. This is right at where the History Center is. So well 36, you can see this green is our wellhead protection area, and that's based off a 50-year time of travel zone. So again, if something spills in this area, it'll take 50 years before we'll see it here. This tighter red area is an emergency response zone. This is modeled using a 1-year time of travel. And then this jagged area here, this is our DWSMA, Drinking Water Supply Management Area. So we have to use features like parcels, roads to define these areas. And this is what, you know, Barb uses these areas when she was at Public Works, planners in town, so they know if they're in a drinking water supply management area. Because, you know, there's some areas where wells are more susceptible than others, so it helps us determine if, for example, if we want to do an infiltration basin. You know, this is here, I'll show this slide quick. This is our vulnerability. So infiltration capability, you can see that things are going to infiltrate really high in this area. So potentially contaminants can get down there a little bit faster. Up here, it's more moderate. So the reason that is, next slide shows where the Decorah Shale is present. So you can see this is a higher elevation. The Decorah edge is right here. So as you're coming, I think the Rochester Country Club is over here. You're coming up that hill, and you start coming down. The History Center sits right here. So that Decorah Shale is present right in that area. That's what makes well 36 one of our better producing wells. We get high recharge that comes over the area right here. And I guess that's my last slide. So I know I was kind of all over the place. I just kind of wanted to give everybody a snapshot. What I do, or what we do at Rochester Public Utilities as far as how to protect the water and how many more wells we'll be putting into the system, how much water we use. And with that,
How long do you think it will take before all 20 new wells are, what is the
well, it'll probably be another 3 to 5 years before we drill our new well. It's hard to say. That's all based on population. I would say it's going to be over a 50-year period, maybe closer to 75 years before we have 20 new wells here in Rochester. Yes?
Where there's an open area in Rochester that's undeveloped, and it's developed around it, are some of those, is geology related to some of those not being developed?
Yeah.
Well, along, let's see, 37th Street, and you know where the J&J produce stand is?
Oh, yeah, that's right by where my office
There might
is.
be others.
Yeah,
That's
it's right off East River Road. Yeah, that's been an undeveloped piece of property.
Are there spaces that are related to geology as the reason?
Well, in that example, I don't believe so. I think that's been for sale for. Yeah, some areas it would be.
And are there some rules or regulations in place as far as protecting the Decorah Shale?
Yes. Yeah, Olmsted County has a Decorah Edge ordinance.
I was in the news several years ago, right off, is it 63? Where you can see it from the highway? 63 going south?
Yeah, yep.
And there was going to be some building there, and then it kind of disappeared from the news.
Yeah. Yeah, that could have been because of the Decorah Edge ordinance. Yes, sir.
If I recall, you said well 20 was one of your better producers, that there was some ammonia showing up. Why is ammonia in groundwater?
So I'm going to repeat the question so they get on the
Okay.
recorder. He was wondering, why are we getting ammonia in well 20, which is that deep, good producing well?
Yeah, it's a low amount. We have to treat it, I think it's because it's in those deeper formations. That's our only well that is that deep. That's the only well we have. And when I say we have ammonia issues, we don't have high ammonia. We have to treat it differently. So I'd say we use a chlorine gas to use bacteria control in all of our wells. We can't use chlorine because it'll react with the ammonia, that small amount that's in the water. We have to treat that one with it's a bleach type solution for in our well 20. And that well is going to go away, I believe. So well 20 sits right down by the Civic Center, and we have a old, it was an in-ground reservoir. God, what's the name of that building that's kind of built up it's got the parking underneath, right next to the Art Center. Well, I don't know if anybody's noticed that reservoir or that in-ground, it's just a big concrete plate. We're going to dig that out this year. I mean, the thing hasn't been in service for a couple years, but that's used to be where the old Rochester Waterworks facility was. So that's where our wells 1 through 5 were at that location. So when we're going to decommission or dig up this old in-ground reservoir, we have to look for these old wells because this is before the well code. So Minnesota Department of Health is making us locate these old wells just to make sure to see if they were sealed right. And if they weren't, then we'll have to seal them at that time. But that's in that same location where well 20. Why they drilled it so deep, I don't know. Had to be an expensive well at that time to construct.
Out of that process then, okay, if you don't know for sure where the well is, I'm sure you do know, how do you go about, 60, 70 years ago to figure out where this well is? You need to take a stick and...
Some people do that, yeah.
So our question was, how do you find these old wells?
Well, that's going to be interesting. What we've done, and I've been out there a few times, Department of Health, and I forget their fancy name. It's a big metal detector, basically. So, yeah. We've located some hot spots. We went back to some of our oldest maps that we could find, any information, digging through these old folders. It's just interesting when you're going back that far to try to find these wells. But we think we've got them somewhat located. Now we're going to go in there. Now when this reservoir is going to be removed, that's the time for us to go in there and do all of our exploratory digging. So basically a backhoe, and we'll start digging around, and hopefully we'll find some metal pipes in there. And actually what's interesting is right where the farmer's market, I think the farmer's market's still down in that area, right about where that is, there's 2 shallow dug wells that are 40 feet deep. they want us to locate those just to see what they were backfilled with. So a lot of times they say, at the time I thought it was a little ridiculous that we got to go looking for these 2 40-foot deep dug wells. But I guess, when they backfill these things, they, throw railroad ties in there, whatever they wanted to get rid of, they throw it in there and then fill it up, cover it up. So it's going to be really interesting. We're going to start doing that this spring, so that area is going to be under construction for a while.
Todd, the archaeologist.
Yeah, it'll be interesting. I'm curious to see if we find these shallow dug wells. So, yeah, and that'll be wells 1 through 5 is what we're looking for. They're making us go back, and all of these older wells, I said well 11 is our oldest well now, so 1 through 10, just to make sure that they were sealed properly.
There used to be a creek going through Essex Park. And then, you know what I'm talking about.
Yeah.
They put in the new sewer line and the creek went away. Is it ever going to come back?
It's a good question. I don't know, Barb, maybe you know a little bit more on this. I know Mike Kraszewski just sent me a bunch of pictures of the dry Kings Run Creek.
Yeah, we're not really sure what happened. There had been some, I'm not sure the right term, it wasn't dynamite, but they were doing some blasting to, yep. And there's some suspicion that maybe through the blasting, we created new fracture flow paths that is enabling the water to flow underground instead of on the surface, because it hasn't changed the water level of the Zumbro River downstream. So the water is still getting from upstream to downstream. It's just not on the surface right now. So it's behaving more like a disappearing stream in karst.
Yes, thinking about chloride protection. Salt that we use in our water softeners, is that a stress to the system? But how does it compare to salt used on roads in the winter when it's we get a lot of frequent snow and frequent salt application? Are both stresses?
So Todd, the question was, how is chloride impacting our water supply, both from water softeners and from road salt application?
Yeah, I would say yes, they're both impacting what we're seeing as far as our trends in our water. I would say most of what we're seeing is the road salts or the salt use in the wintertime on the roads. Not so much for the chlorides from the water softeners. Because when that gets to the water treatment plant, which is right on 37th Street, all that water gets clean. All those chlorides do not get removed. They do get back into the South Fork of the Zumbro, which moves north out of town. So I would say the chlorides that we're seeing in our groundwater here in Rochester are probably primarily due to the salt use in the wintertime.
And I can speak to a little bit about what the Public Works Department has been doing about that. It's like 4 years ago, they started a process of computerizing all of their dump trucks that are applying the sand salt mixture, and they have now both the technology to measure the pavement temperature and to calibrate their equipment so they're not dumping unnecessarily. And they've also switched to a brine system, which when you know that you're going to have a certain type of storm event, especially like a freezing rain event, they can go and put down strips of brine, and then that will enable less sand and salt use once the freezing starts. It's called anti-icing. So they've been working through technology to reduce their salt consumption on a per mile road basis, but Rochester's been getting bigger, so there's more miles to take care of during the winter, and the demands that people have for accessibility, no matter what the storm event, have not gone away. We've also, the Public Works Department last winter had done a series of workshops with folks that are on the contracting side of it to try and get them more aware of the impacts of chloride contamination, because those systems are typically using people that don't have any training, they don't have any calibration system, And what you see out there on parking lots and ramps is more is better still. So that's partly an education thing, and it's partly a safety thing because we heard from contractors that have tried to put on less, that the people they contract with have not found that satisfactory because they're afraid of getting sued for a slip and fall. So it's a bit of a conundrum.
And then to talk about chlorides in the wastewater side, and I know David Lane, he's the environmental coordinator for the water reclamation plant here in Rochester. He did a presentation a month or two ago at Cascade Meadows, and he said that's their permit might change, and it's going to tighten up on how much chlorides they can, put back into the system after they clean the water. So right now, the way the water treatment plant's set up, it doesn't treat for chlorides. So they'd have to change their process considerably and cost millions of dollars if that law or the permits change. And it's, primarily chlorides in the wastewater side are from the water softener regeneration.
And
So they're concerned about it, and it's gonna, ultimately that'll get passed on to the customers too if they have to revise or change how they treat the water.
And newer water softeners have a demand system, so they're actually inputting less chloride into the system than older ones.
Yes?
Average year, Todd, what do we waste keeping our lawns green and pumping pristine water out of the ground?
Non-essential use. Yeah, so DNR is, they're changing their process as far as what that number is. We get charged a summer surcharge. Basically, we look at June, July, August, and January pumpage. So January when it's cold, nobody's out using their, watering their lawns, obviously. So we subtract those 2 months so we can determine just how much water is using in the summer. So the DNR charges Rochester Public Utilities more for that non-essential use. And that, we're at about 4.7 billion. I want to say that's in the 300 million gallon range as far as the non-essential that we get charged for what we call that summer surcharge.
In the metro area, the amount that the Met Council is estimating is that people use about 50% more water during the summer, and it's all attributable to irrigation.
Yes.
This question was probably for Barb, and I missed it, so if I missed it, you can correct me. When you were talking about that one, I'm going to say creek that was drying up, and you're kind of trying to decide, when you decide you're going to redo it, how do you redo it? And is this similar to if a farmer put in a pond and you have to get everything all prepped, or how do you prep it?
So that was actually was constructed as a stormwater treatment pond, and in order for ponds to have a water quality treatment benefit, they have to retain water for a period of time so the sediments settle out and so that the water is treated through sunlight and through plants, and all of those things help treat the water quality or improve the water quality. In that particular case, it didn't leak the first year, so there wasn't any suspicion that it had not been constructed correctly, and it started leaking more over time. So potentially, if the city decided to go back and make it a wet retention pond again, they would just bring in clay and make a clay layer. But since that pond was built, the regulations for stormwater management have changed, and now cities have to do both water quality treatment and they have to provide for water quantity. So you have to recharge a portion of the stormwater that falls on the ground back into the ground itself instead of letting it run off. So there now may be some value in keeping that as an infiltration pond, so it gives us credit toward that infiltration need of the permit.
So what is the purpose of the pond that's just north of the patching all across from Old Highway 14?
The ponds in the interchange there?
Well, it's along the frontage road. It meets up with 14th Avenue.
Yep. Those were all built by the Minnesota Department of Transportation with the improvements of the roadway, and so those are water quality treatment ponds that were built as part of the road project. Yep. So if you see wet ponds, they're typically,
It's always got water.
yep, those are typically water quality treatment ponds.
So they put chemicals in it?
No, the stormwater that runs into it gets treated through 3 different ways: through ultraviolet sunlight, breaking down some of the chemical compounds, through the settlement of solids, so sand, and so periodically stormwater ponds have to be dredged. And then also the plant community that grows along the edges and the algae that grows inside, they take up the excess nutrients. So they're a lot like the same kinds of processes that are at work in the wastewater treatment plant. So nature is a great, Mother Nature is smart. She knows how to take care of things in the system as long as the system isn't overwhelmed. And so stormwater ponds typically serve a pretty small area. I saw a hand over here.
I'm going to defer to Ruth Ann.
Todd, just a quick question. Is anybody working on gray water systems for toilets and lawn watering and that kind of system?
I think we'll see more of that here in Minnesota or in Rochester. When you say are people working on that, I mean that's going to be individual businesses or residential that retrofit how their water's used, so they can use that gray water to use it as irrigation on their lawns, gardens, things like that. So it's nothing that are working on as far as Rochester Public Utilities. Yes, we would encourage it, and I think you're going to see that more and more, even in Minnesota.
But it's an individual.
Ruth
Yes.
Ann, I think one of the barriers to that happening in Minnesota right now is the state plumbing code.
Yeah.
And there would need to be some significant changes in that before it would be facilitated.
And I just want to add one more. When you asked about the summer use and how much water we're using, so one of the things that we changed, and this was about 3 years ago, we implemented water conservation rates. So it's a tiered rate approach for how much water. Use more water, you're going to pay more. Now these 3 tiers, they're still less than, they're too cheap. And I know that, we all know that. Nobody's going to change their habits, or if they want a green lawn, they're going to pay the extra. In reality, it's pennies, maybe another $40 to have a green lawn for the summer. Our water is that cheap. We do have some of the lowest water rates here in Rochester, or in Minnesota. And it's about you can use 750 gallons and it won't even cost you $1. So, but we do have these tiered approach just to make people think if they're going to be using more, they're going to be paying more. And now on the irrigation, all commercial or industrial that have an irrigation system, it's got to be metered separately. So we automatically, any irrigation meter is at the highest tier. So that's, these businesses, they're going to want to water their lawns wisely. I mean, how many people have driven by and when it's raining out and see the irrigation sprinkler systems going off? So with these smart sensors, smart irrigation control boxes, a lot of that is changes. What's that?
Are those new meters retroactive? No, I'm serious, are they?
They should.
Or just new big irrigation systems?
It's for commercial and industrial that would have a separate irrigation meter.
Beginning when?
I don't know if they are retroactive.
Okay.
What, you must have one that isn't at that highest tier, or know of one?
Actually, I put in sprinkler systems.
Okay.
And I'm just curious because there's a lot of wasted water in those.
Yeah.
There's big systems that don't even have a rain sensor on them.
And the law has changed, so all new ones have to have that. Yep. And it's, I don't know, I'll have to ask that question when I get back to the office on Monday, tomorrow.
One more question.
Well, I was just wondering if you had any comments about rain gardens.
Well, I actually do have comments about rain gardens. Part of this new permit, that's this new stormwater permit that the city has with this volume control requirement, is going to change the way city does business, and you're going to see fewer and fewer of these larger regional ponds and more different types of best management practices that provide both water quality treatment and infiltration. And those are things like bioswales and rain gardens and infiltration trenches. And the idea is, behind this, is to get cities to start mimicking the hydrology that used to be here before the city developed, so that we keep as much water as close to where it falls as possible, because all of our natural systems are dependent on that water. And if we keep shunting it away, then those natural systems can't benefit from it. So I think over the last few years, you've seen more of those kinds of best management practices as you drive down 2nd Street Southwest. You see a lot of that. You're seeing it more in the new developments that are coming forward, and that's needing to meet the new regulations. But Rochester has a cost share grant program for residents that want to install a rain garden, and the payment is up to $750 or 50% of the project. And we've seen some really clever and beautiful rain gardens that people have installed. So if you're interested in that, go to the stormwater website, rochesterstormwater.com, and just type in rain gardens and you'll learn about that program. I think the due date for applications is May 1st. You'll have to look on the website, but I'll make a plug for one other thing that's on that website, and that's called the Rochester Water Primer. So if you go to the website and click on the Citizens link, and then under the Teacher tab, there's a document called the Rochester Water Primer, and it gives a chapter on different water topics in Rochester. So there's a chapter on the city's flooding history, there's a chapter on stormwater management, water supply, wastewater treatment, what our natural water features are, our artificial water features, along with a lot of resource information. And you'll be amazed to learn how many miles of storm sewer and water line exist in
It's
this
a
city.
neat report to look through.
I'm prompting you on something. There's another feature you didn't talk about in terms of retaining on site, and that's the long-term cost of revitalizing all of these stormwater ponds. What's the city banking to look at that in the future?
Well, the city's been doing maintenance on the ponds since 2003, and that maintenance includes removal of woody vegetation, mowing, and the mowing frequency depends upon where it's located. So if it's part of an environmental corridor, it maybe only gets mowed once or every 2 to 3 years. If it's in a residential neighborhood, it might get mowed 3 or 4 times a season. So the maintenance costs vary, and one of the things we started doing when we started doing our vegetative maintenance was inspecting our ponds to see what other kinds of maintenance they needed. So we've been trying to stay on top of it, so it's an ongoing operations expense instead of a big project expense somewhere down the line. But all the ponds will need to be dredged at some point, and I think initially the city was thinking they were going to need to dredge them once every, 10 or 15 years, and that's not proving to be said. As the city has improved its program working with contractors to provide erosion control on new developments, they're seeing less input into the stormwater ponds. So we're not, we will have to dredge periodically, but the ponds are functional up to 50% of the capacity of the pond, and the price of doing them depends upon the size of the pond, the access of the pond, how much is in it, what kind of material it is, where we have to take it to dry it out before we can stockpile it. So there's no common cost per square foot of ponds that we have yet.
Are all the ponds seeded the same?
No, the choices that were made on the early ponds, they were allowed to be kind of bluegrass dominant. Since about, I'd say 1998 or so, they really made a big shift to using native vegetation because those long native roots are super good at treating pollutants. And part of the reason we're doing the mowing or the burning and some spot spraying is so that we can maintain those healthy native vegetation.
Any overseeding going on at all?
Not in the earliest ponds, there has not been.
I live in the northeast, and the drainage ponds there, including the ones by Quarry Hill, and I think they might be city and private development, are basically completely overrun by Palm Dutch. No one seems to be doing anything about it.
Well, those two that are in that Quarry Hill area, the project actually exacerbated the crown vetch that had been put on those hillsides at the time of development, and there is no way to control it. We did a complete eradication of the crown vetch before we did the construction, and after the construction it came back, and there's no way to eradicate it unless.
But like the one by nearest my house, I watched the area go from like less than 100 square feet to thousands of square feet in the last 5 years. And I tried little things to do it, but I can see it's totally
Well, that would be a good topic for another day. Invasive species and management in urban areas is exceedingly difficult.
You're saying there's no way to control it.
It's a choice about where you spend your money.
Barbara, you gonna hang around for a while?
Sure.
Todd?
Sure.
Well, I'd like us, out of respect for the library, we need to end the program, but we could go on with questions